My name is Cliff Medling, and I'm going to be your host. We're going to jump right in as we have a lot to cover in just 22 minutes. First of all, using GoToWebinar, if you're new to it, we recommend that you view in full screen mode, as we will be showing a demo inside of SOLIDWORKS. Also, if you have any questions during the presentation, please type them into the question field, and we'll get to as many of those as we can after the 22 minutes is up. And we will be showing poll questions. So these are, to keep it interactive, there'll be poll questions on your screen, and you'll have multiple choice options where you can select, and we'll be sharing the results from those polls as well. So we only ask that you answer those poll questions quickly to keep within our time frame. And with that, we're actually going to jump right in and launch our first poll here. And what do you do beyond mechanical design in your job now as a designer or working with SOLIDWORKS or our products? So please answer that. And while you answer that one, I'm going to introduce our presenter. Unless you're new to the SOLIDWORKS community, I'm sure you're familiar with Jeremy Regneris. He is the Senior User Advocacy and Community Manager for SOLIDWORKS. He has over 17 years of industry experience. 15 have been with using SOLIDWORKS. Jeremy spent time designing agricultural equipment, automated assembly machines, too many A's there, to classified vehicles for the defense industry. He's also worked as an applications engineer prior to joining SOLIDWORKS 7 years ago. Since joining SOLIDWORKS, Jeremy has focused on creating rich user content, product demonstrations, and what's new material. And he does a lot of videos and blogs and how-tos for our community. So I'm sure you may recognize his voice. And with that, I'm going to close the poll before I hand over to Jeremy and share the results. And product performance, 33%, and manufacturing analysis work, 32%. So those are the two highest. And with that, Jeremy, it's all yours.
All right, thanks, Cliff. Welcome, everybody. What I want to discuss here today is talking about the design process, more so beyond your typical 3D mechanical design. I think most people are familiar with SOLIDWORKS as a great 3D design tool, but there's other areas once you start to branch outside of the basic elements of 3D design, and this involves things such as managing groups of people, understanding the performance of your products, controlling and managing both the cost and the quality associated with your products, collaborating with other organizations, for example, electrical engineers, PCB Design, customers, suppliers, and finally communicating your designs, whether that be final deliverables for things such as instruction manuals, or communicating with a customer up front how your final product's going to look. So what we're going to do today is we're going to go through sort of a marathon of SOLIDWORKS products using this refrigerator design you can see over to the right, and show how a lot of different SOLIDWORKS tools can be involved in both the design process, from simulation to collaboration to understanding cost, all these topics that we have here. So this is going to be really fast, and by no means is any topic that we're going to cover going to be covered in depth. There's a lot of great material available on the SOLIDWORKS.com website, or at the end, Cliff will ask another poll question whether or not you'd like more information, and you can definitely raise your hand for that, and we can provide you with more information on these products. Now, I'd like to dive in and look at one more poll question here before we go ahead and actually get started in the marathon of these tools. So, Cliff, if we could go ahead and show that. Basically, what products beyond the SOLIDWORKS typical design tools are you using today? Are you using PDM tools such as ePDM or Workgroup PDM? Are you using any simulation tools such as Flow, SOLIDWORKS Simulation, Plastics? Is anybody using SOLIDWORKS Inspection or the new electrical tools that are available? And finally, SOLIDWORKS Composer.
Thanks, Jeremy. Going to give, if everybody could vote, give everybody a few more seconds. It looks like still a few that haven't voted here. And then I'll close it up. All right, let's close up the poll. And the results, a lot of people using simulations. That's great. And obviously, PDM is second. So inspection is new, so not surprised by the low numbers there. Okay, back to you.
All right. Sounds good. So let's go ahead and dive right in then. As I mentioned, we're going to take a look at a lot of products and how they're involved in the design process. And usually designs start with managing all that data. SOLIDWORKS Enterprise PDM is a great tool for file and data management, more than just SOLIDWORKS files. It's also a powerful tool for revision and, probably more importantly, the control that users have over specific types of files. And finally, I think search and where used are critical to making sure that you can find your data and where it's being used. So SOLIDWORKS Enterprise PDM is great for managing the vast amounts of engineering data associated with a project. Whether it's simple file management, revision control, or approval processes, it's the foundation for everything you're going to do. You can see it's integrated inside of Windows Explorer, but it's also integrated directly inside of SOLIDWORKS. So we can open directly from inside or Windows Explorer into SOLIDWORKS, and as design changes take place, this information can be shared directly with other users immediately by simply changing a state. Once the state's changed, designs go through an approval process that you can set up that's customized for your organization, and the recipients get quick emails that allow them to find that data easily. So for example, if an engineering manager needs to approve a design, he can go ahead, simply click approve, say it looks good. As I mentioned, it's also integrated directly into Windows Explorer. This is great for finding where information is used or bill of materials. So for example, we can see what it contains, or here, where a particular item is used. So if we look at a door handle assembly, we can see all the other assemblies that it's used in. It makes it really easy to manage and find that data wherever it's going to be used. So Enterprise PDM is great for managing your data, but what about understanding the performance of your components? This is where SOLIDWORKS simulation really comes into play. It allows you to understand how your parts are going to perform, to find failures in those designs early on, but more importantly, allows you to validate how multiple design scenarios will affect an overall design. So SOLIDWORKS simulation runs right inside of SOLIDWORKS. So for example, if we wanted to take a look at the strength of this hinge bracket at the bottom of this door, it's really easy to set up. All you need to do is use simple terminology such as applying a force. And in this case, we're going to apply a force to the top of a bushing, set what that force is going to be, and you can switch your units. We also simply specify how these components would be fixed in space. Now we could use the whole assembly, but to keep things simple, we can work on just a subset of data. In this case, we're going to use the preload from a fastener to specify how this bracket's going to be defined. Then you simply go ahead, run your analysis, and SOLIDWORKS simulation gives you results that are really easy to understand quickly and to help you determine the strength and the results of your parts. So in this case, this bracket might not be strong enough. So a way we could improve this is by adding some gussets to the bracket. With SOLIDWORKS simulation, you can just duplicate a study, rerun it, and quickly look at the results for a new variant. You can take that a step further and start to look at different mounting configurations with those gussets in the other orientation, until you get to a solution that's going to give you exactly what you're looking for. So understanding not only the performance but different variants is a great way to better understand your designs inside a SOLIDWORKS simulation. The simulation isn't just stress. It can also involve things such as understanding the performance of flow through your design. In the case of this refrigerator, we need to understand heating and cooling properties in somewhat of a real-world scenario. SOLIDWORKS flow simulation, very similar to SOLIDWORKS simulation, is pretty easy to set up. In this case, we're going to take a look at these cooling channels in the back of the refrigerator, and really quickly we can set up things such as the atmospheric pressure for these inlet vents here. Then we'll go through the process of specifying where the fans are going to draw the material through. Now you do this by simply setting an outlet, and we can capture this information from the manufacturer of our fans, or more easily we can actually use an internal or an external fan built right into SOLIDWORKS flow simulation. Choose the inlet and outlet faces and select from a wide variety of fans that are included in SOLIDWORKS flow simulation, and then just run the results. Because flow is a complicated calculation, we can use multi-cores on our computers to definitely benefit from that added performance. And when the results are done, we can quickly see how the flow of air through our design is going to perform. This gives us immediate visual feedback that allows us to understand, do we need to make changes to our design? This might be things such as the density of airflow, the velocity of airflow, or high and low pressure spots. So we can use this to determine, for example, that the upper fan is performing really well, but maybe some of the other fans need to have some design changes to them, and how we determine how we're going to move air through our design. So we've looked at using simulation for understanding your product, but what about using it in manufacturing? This is really where SOLIDWORKS Plastics comes into play. It allows us to understand that injection molding process in a much better way, but also we can use it in the product development to find cosmetic and structural issues and to help us build better molds as we go through the manufacturing process. You guessed it, it's a lot like the other products. We can go ahead and start working on a part right away. In this case, we're going to choose one of the door shelves, and all we need to do is set up our mesh. Now, SOLIDWORKS Plastics really walks you through this process. It's got a bit of a step-by-step wizard over on the left-hand side where you can, if you don't understand all these things, it'll help guide you through that process. What you really need to specify is, where is the plastic, where would you like the plastic to be injected at? So in this case, we're going to go ahead and choose an injection location, the diameter of the injection, but we can also use the runner design wizard and access a massive library of plastics materials which are lab certified. Then, like many of the simulation products, we run the results, and SOLIDWORKS Plastics is going to help us with the results advisor on the right-hand side understand the flow characteristics of our plastic injection. Here we can look at fill time, but you can see on the upper left-hand side we can find other information, such as those cosmetic features, such as weld lines in our designs, which on a clear part might make the part not look as good. So we might want to make some changes based on where we do injection. Likewise, sink marks are important on plastic parts. But you can see there's a lot of information that can be gained here, such as temperature information, fill time, and all of this information, such as the residual stresses that are generated during the plastic injection molding process, can be used in SOLIDWORKS simulation. So simulation isn't just for designing your parts, but also the manufacturing process. At this point, I'd like to stop and capture everyone's attention again. We're going a little fast, and do another poll question. Cliff, if we could show that, how many people outside of your engineering department do you need to collaborate with? And this could include customers, suppliers, other vendors, design houses, things like that.
Great, thanks, Jeremy. So going to give everybody a few more seconds, and I must apologize for the last poll question. I didn't give people multiple options for the product, so my apologies. All right, I'm going to go ahead and close the poll and share the results here. And as you can see, 41% are the 4 to 8 group.
So it sounds like people definitely have to work with others outside of the engineering group typically. And this is really what we're going to cover next, some of the tools that allow us to better understand that. So let's go ahead and start by understanding, controlling the cost of your design. Sometimes this might be working with a supplier or even your own internal manufacturing group. Costing allows you to find cost-prohibitive items really early on in the design process, but more importantly, to understand how specific features impact the cost of your designs. And like simulation, we can quickly compare different design scenarios and see how cost is affected. So let's go ahead and take a look. For this example, we're going to go ahead and take a look at the welded frame on the bottom of this design. When we pull this up, costing is nothing more than a button click that brings up a really easy to understand dashboard on the right-hand side. Using templates that you can set up by collaborating with your suppliers or manufacturing organization, you can quickly develop information that determines the cost of the individual features in your designs. We say calculate the cost estimation, and we get some quick feedback. In this case, we can see the general cost, but more importantly, we can make modifications that drive how individual bodies generate their cost. In this case, instead of a milling operation, we chose that this was going to be turned. We can see every body and feature in our design, and as we make changes to our design, we can set a baseline for a cost, in this case $256, and we can go back and make changes, such as adding gussets and holes to these features, and simply clicking Update in the dashboard, we can see how those changes are going to drive cost. All cost, obviously, is a balance of the part performance versus what you want to pay, and so it's important to be able to communicate these designs, either with management or with suppliers who you're going to bid out a project to. SOLIDWORKS costing allows you to quickly generate reports. In this case, we can see what the cost of each one of the items in this design is and how that's driving the overall cost of the part in this design. But cost sometimes isn't just the cost of manufacturing. There's other things we want to look at, such as quality. When you want to develop QA documentation to ensure quality parts, you want this process to be easy, and SOLIDWORKS Inspection allows us to quickly retain our design intelligence and generate quick and easy outputs. So for this example, we're going to go ahead, like before, we're going to take a look at one of the parts in our design right here, and we have a drawing for this. In SOLIDWORKS, you can specify specific dimensions to have the inspection characteristic to it. And then with SOLIDWORKS Inspection, we can generate a report or an inspection documentation very easily by using information from the SOLIDWORKS document. So here we can choose to include the inspection marked only dimensions and any other information we're looking for. We can also drive our inspection documentation based on our overall tolerance. Once we do this, SOLIDWORKS marks each of the dimensions for an inspection sheet, and you can see we can go through this process and make changes to these if we need to key or flag a specific dimension. Finally, the last thing we can do is quickly export this to an Excel document to generate our first article inspection reports. In this case, it's really simple. We're inspecting 6 dimensions on this design. But the real power is to quickly balloon everything automatically and generate really complex reports, which is going to drive your downstream QA process. So leveraging that engineering data to help create that documentation really streamlines that whole process of going from design to manufacture to quality. So let's continue on here. I want to talk a little bit more about the more traditional collaboration tools inside of SOLIDWORKS, eDrawings and PhotoView 360, allowing you to really easily share your designs and ideas with others, but also to create visually appealing content that's also simple to understand. I think most people are familiar with eDrawings, but let's take a quick look and see what eDrawings really allows us to do, specifically with eDrawings Professional. In SOLIDWORKS, we simply need to choose to publish an eDrawing, and it provides the end recipient on any type of a computer, Mac or Windows, the ability to measure. They can also apply markups, so they can collaborate their thoughts on a design process with the original engineer. So for example, if you're concerned about the depth, maybe somebody else is designing that PCB board, they can share that information. Additionally, once the recipient receives this information, they can really quickly collaborate with the original person who reviewed that document by the fact that eDrawing saves all that conversational information. Likewise, PhotoView 360 allows you to create photorealistic renderings to communicate in a different way. Though eDrawings is good for collaboration during the design process, PhotoView 360 makes it really easy to generate images of what the final product's actually going to look like. This is great for reviewing designs with customers or using this information both in sales and marketing collateral down the road. You can generate a lot of images, really nice images, using PhotoView 360 to help share those ideas. Sometimes collaboration is more than just customers and suppliers. Sometimes it might be other groups inside of your organization. For example, you might have a group that does PCB or circuit board design inside of your organization, and you need to collaborate their electrical engineering information inside of SOLIDWORKS. CircuitWorks is a great tool that allows you to collaborate with these users. You can start inside of SOLIDWORKS and create a general idea of what you think you're going to need and export this information to CircuitWorks. This information can then be synced with ECAD using EDMD. So here I have a basic idea of what we want, and we can collaborate that information. But likewise, when the electrical engineer makes their changes, we immediately can see how those changes are applied and compare the two side by side. Finally, we can then take those changes from electrical engineering and build that model directly inside of SOLIDWORKS. It's really quick and easy. Likewise, if the design starts in ECAD, we can actually open a variety of native ECAD formats, such as PADS, IDF, and ProStep files inside of CircuitWorks and generate those models just like we saw before. You can filter this information to see to get a better understanding of the design early on as well. So there's circuit board design, and then the other half of electrical is the schematic side, the actual electrical schematics themselves. Electrical engineers and mechanical engineers typically lived on these different sides of the wall. Well, SOLIDWORKS Schematic allows 2D electrical schematics to be generated and shared with SOLIDWORKS seamlessly. Let's go ahead and dive in and take a look. In this case, we want to generate a wire harness for that cooling chamber we saw before. Here's an example of it. We're using SOLIDWORKS Electrical. We work inside database-driven projects. We can open these up, and SOLIDWORKS Electrical allows us to tie directly to that data, but we can create multi-line diagrams and single-line diagrams right inside of SOLIDWORKS Schematic. Using the powerful library, we can quickly search for components and tie those to specific components in our design. Here you can see I can quickly copy and paste to create multiple fans, and then when it comes time to create the multi-line diagram, again, we can use that same powerful database to find our common symbols and simply drag and drop them out into the graphics area. Like before, we'll associate those to the actual components in the real world. You'll notice it's easy to copy and paste these components too. Just reassign it to the correct fan, and the information on the tags updates automatically every time we do this. Likewise, if you want to specify locations, it's as easy as drawing a location outline inside a SOLIDWORKS schematic. You can tie all these components to a new component location, and that information is updated everywhere. Now, when it comes to integrating this inside of SOLIDWORKS, now we want to look at the 3D side of this. And this is where SOLIDWORKS Electrical 3D comes in. We want to leverage the intelligence of the 2D schematic information in our 3D model. We want to do this to generate our electrical harnesses using the built-in auto-routing technology. So, like we saw before, it's directly tied in to SOLIDWORKS, the 2D schematics, and you can see all that geometry or information we created there is available right inside of SOLIDWORKS, so we can review those documents anytime we need to. And if we're inside of a file, you can see using the you can see when you're using SOLIDWORKS Electrical, any components at any tier show up, and we can associate those with previously inserted components. In this case, we're going to associate that with an existing fan. Likewise, you can use this to actually show you which components need to be added to a design. So here, we're capturing the information from the electrical schematic and filtering this information down until we've inserted all the necessary fans in our design. Once that's done, we can use the powerful routing information to help generate our wire harnesses. In this case, we can use a sketch as a general guideline, and then SOLIDWORKS will build a wire harness based on that information. Using traditional SOLIDWORKS routing tools, we can use this then to flatten these wire harnesses and create manufacturing information, such as pinboard drawings or typical bills of materials. And the great thing about this is we're capturing all the important information, such as the lengths of our individual wires and cables and from-to information as we go through here. But routing is more than just electrical components. You also have pipes and tubes you might need to incorporate into your design. In this case, we want to make sure we're documenting all of our tubes and pipes that go into our designs like we did the electrical components. So in this case, we're going to take a look at some of the cooling information on the back side of this, and we want to add some hoses. You'll notice with an intelligent library, when you drag and drop components, SOLIDWORKS limits your choices based on the chosen information. Here we can only choose between 10 and 8 millimeter hoses based on the clip that we've attached. Auto routing makes it really easy to route from one component to the next, and you can easily make adjustments on the fly to make sure that your tubes and pipes aren't interfering with any components. This is something a lot of people oftentimes leave out of their designs. All the parts are intelligent, so for example, if we drop some T connectors in, you can see that SOLIDWORKS automatically segments our tubing, and for manufacturing, we can further break this down into what are called spools, which are kind of how you would manufacture these individual subassemblies of a route. You can go through this process, define all the spools, and then when it comes to creating the documentation, just like a wire harness, SOLIDWORKS does almost all the work automatically for you. So here it's going to generate a sheet for each one of our spools, and it's going to add a bill of material so manufacturing can quickly get these manufactured. Once it's generated, you can make any of the necessary changes that you want as you go through here. The last thing we want to look at is some of the final documentation. It's not necessarily final, but technical publications is one of the things that's often thought about at the end of a design. And the important part of SOLIDWORKS Composer is that you can develop this documentation sequentially with the rest of your mechanical design. SOLIDWORKS Composer allows you to create beautiful technical publications that go beyond simple drawings. These would be things such as instruction manuals. Let's take a look at trying to show how to assemble this drawer inside of SOLIDWORKS. The process is, it's not really tailored to this. If I want to move these components, SOLIDWORKS isn't necessarily the right tool. Well, SOLIDWORKS Composer allows us to open these components directly in its own very lightweight and streamlined environment. From here, we can change a variety of graphical settings to get just the look we're looking for downstream publications. So you can see I can customize and tailor the look and feel to the type of technical publications we create. I usually like to settle on a typical white line type diagram. Then, using the context-sensitive tools, it's really easy to manipulate the geometry to show how an assembly might go together. This is something, as I mentioned, you might show in an instruction document. But we can create more than just instructional information. We can also generate information for replacement parts, for example. We can really quickly and easily balloon all of our components and add a parts list to the design that's not only graphically appealing, but it's really intelligent. So for example, in an HTML, in Windows Explorer or Chrome, you can see we get this interactivity that we can then hyperlink to and actually build almost like a replacement parts ordering. So we've gone through really quick. I'm sure we've gone well over our 22 minutes here. But we've covered a lot of products inside of SOLIDWORKS. And hopefully what you've seen is SOLIDWORKS is a lot more than just 3D mechanical design. There's a lot of other tools to help you solve other challenges beyond the typical manufacturing process.